Hi! In today's video, we'll be learning about an important Python concept, which is user-defined functions in Python. And we'll be covering topics like what are user-defined functions and why are they important. As well as, with the help of Python code, we'll be studying what is the syntax of user-defined functions as well as what are parameters inside UDFs. So, let's go! So let's understand what is a user-defined function. A user-defined function, or also known as UDF, is a custom set of rules or formula or a set of Python code which is written by the user, which is nobody else but us. So let's consider an example. This is a user-defined function which returns the square of a number. But this is a very small example which has just 2 to 3 lines of codes. However, a user-defined function can have hundreds or multiple lines of code, which can be a very big chunk. But what's the benefit of this user-defined function? The number one benefit is usability. When you are using a user-defined function, then you don't need to write those hundreds of lines of code again and again if you want to reuse them. Rather, you can create a UDF, and then when you're using it for the second time, third time or more, then you can just simply call that UDF. So in other words, it saves you from tons of typing and reduces your risk of error. And another major benefit of UDF is organization and readability. Let's say we have got multiple UDFs, where one is for filtering the data, another one is for imputing the missing values, another one is for removing duplicates, and another one is to run my linear regression model. Then I know which UDF does which function, and it becomes easy for me to manage my Python code, as well as it enhances my readability. So this was theoretically about what are UDFs in Python. Now let's move to our Python code. In Python, user-defined functions can either be used for printing something or returning a value. Let's start with simple things, which is, let's say, printing a value. So let's create a user-defined function for which we would need to indicate it with a def keyword. This is a reserved keyword in Python which indicates that is I am creating a user defined function for me. Now suppose this is a name which I want to give it. It can be any name which as per your liking. Suppose I want to call it print function. So I'll write it as print underscore function, and currently it is not taking any parameters. What are parameters? We will be learning it in a moment. So I'll write it as parentheses, and then after it, I will write a colon. A colon indicates that I have defined my function now, and I'll press enter. Notice that it has added an automatic indentation, so we need to be respectful of it. Now over here, let's write print hello world. And then, is it printing anything? No, because we have not called the function yet. For calling a function, we will just write the name of it. That's it. And I'll write the parentheses over here. Notice it has printed hello world in our output. As I mentioned earlier, user-defined functions can also be used to return a value. Let's create a UDF and let's call it my function, and it will return 2 plus 2. So I'll write it as def my function 2 plus 2. Now to call this function, let's write it as my function this thing. And it's now returning this 4 as an output. And you know what? We can save this output in any variable. So I can write it as x is equals to my function. And if we now print the value of x, we can see that x has been stored over here. That's what the difference is between a return statement as well as a print statement. If we try writing x is equals to print function, then hello world will not get saved in x. Let's give it a try. X is equals to print function. It's printing hello world in the console. However, if I write print x, see it's saying none because the value has been printed over here. While when a value is returned, it can be saved in a variable. It's not that in a user-defined function we can only print values or return values. We can do both. Let's take this example. Over here in my function, I am printing hello world as well as I am returning 2 plus 2. So if I write this thing, x is equals to my function, and if I check the value of x, see 4 has been stored as well as it printed hello world. Let's move to talking about parameters in UDFs. Suppose if I want to create a function where if I give it any number, it will return the square of it. For this, we will be using parameter. So let's create a function called def. I'm calling it square function, and suppose the parameter over here is x. This x will get treated as a local dummy name. Now if I write return x square, that's what it will do. Let's see. If I write square function bracket 3, what it is doing is it's assigning the value 3 to x, and then it's returning 3 square, which is 9. Similarly, we can do square function 8 and it will return 64. That's why parameters are very useful, because it allows you to use the same function. In any function, we can have multiple parameters. Let's take an example. Suppose if we want to create a UDF for calculating BMI. The formula for BMI is weight divided by height square, where weight is in kilograms and height is in meters. So let's see. Our function is def BMI, and if I write it as, let's say, height comma weight, and if I return weight divided by height square. Thus, to call this function, there are two ways. I will either write, suppose my height is 1.6 meters and my weight is 55 kilos. Then it is returning that my BMI is 21.48. So over here it has automatically assigned 1.6 to height and my weight as 55. What if I change the parameters? If I write something like 55, 1.66, it will assign 55 to height and 1.66 to weight, which is an incorrect calculation. So if you know the order of the parameters, it's good. Otherwise, you can specify the names. Example, here I can write height equal to this and weight is equals to 55. And then in this way, I can switch the order. You know, in UDFs, we can also provide some default values to these parameters. Let's again copy paste this UDF over here. And over here, let's suppose if I say my weight is by default 50 kilos. And if I now write this thing BMI let's say my height is 1.6, and if I am not providing any weight, what it will do, it will automatically treat my weight as 50 kilos. Now, but if I give 1.6, 55, then instead of 50, it will take my weight as 55 kilos and then it will use it in this function. One thing to note over here, that is, the default arguments must come after non-default arguments. What do I mean by that? Let's try this thing. Over here, let's write height is equals to 1.6 as a default, but let's not give any default value to weight. Can I create a UDF like that? Answer is no. Let's try doing it. See, it gave a syntax error. Let's see what it says. Parameter without a default follows parameter with a default. That is, parameter without a default, which is weight, is following a parameter with a default, which is height. That's why when creating a user-defined function, all the default values must come towards the end. You know, a function can also return multiple values. Let's reuse this function. Over here, I'm renaming it as BMI calculator, and let's save this thing in a new variable. Let's call it BMI. So over here I'm saying BMI is equals to this calculation, and if I want to return three things, which is height, weight and the BMI. So I'll write it as height, weight, BMI. Now if I call BMI underscore calculator, let me give the height as 1.6 and weight as 55. See, it's returning three things and we can save them in three different variables. Let's say if I write A, B, C and write this thing. So we will notice A will have the value 1.6, B will have the value 55 and C will have the value of our BMI. So that was all about user-defined functions in Python. Do let us know in the comments below how did you find this video, and stay tuned for more upcoming content on Python. Until then, see you soon.